Right, welcome back to part 2 firstly, and let's make some spawn points. The way a spawn point is going to work is a period of time will pass, it will create a new instance of an object. That object can go and do its own thing. So if you've got some previous examples of when we used our zombie and you had your zombies moving, that is something you can do to add additional complexity in a moment, to perhaps make... That's ugly. Making the enemy chase the player or something is an optional bonus point. However, for now we're just going to have them spawn in, and we're going to have some fun by making them physics objects. And as those physics objects spawn in, they will try and push each other apart. So we can have some fun with that and fiddle with the numbers a little bit. Spawn points usually aren't a physical object. They're not like a I don't know, like a cloud of dust or something that spawns something in. Usually they're just empty points in space that instantiate new objects. So firstly, we need an object that we are going to spawn in, and that object will be a prefab. So we're going to create just a simple 3D object, which is going to be a cube. I'm going to go into my materials folder and make my cube red by creating a new material. I'm going to call this new material red. And I'm going to change its base map to be red and drag and drop that onto the cube. There we go, we have a red cube. I'm now going to go into the prefabs folder and drag and drop our cube into the space, and then you can delete your cube out of the hierarchy because you can now make more of it. There we go, we've got a red cube. Don't know why the preview's not showing it red, but it's a red cube. What we now need to say is create an object, an empty game object, and apply a script to that empty game object. I'm just going to minimise this coins as well to keep things nice and tidy. Remember, that's what we did at the end of last video. Let's create an empty game object. I'm going to call this spawn point. And if you remember from one of our previous videos when we were creating points in space, they are invisible, so you can't get an indication of where they are. However, you can change it by choosing the little icon next to the arrow. You can select that and choose something to give it a just something that's visible in the editor, so you get a rough feel for where it is. I'm going to choose something purple, and I'm going to put spawn point roughly smack bang in the middle of this underground space. Let's go with that. So we're going to write a spawn point, and the spawn point will just say wait a period of time, instantiate something, and spawn that thing in. So let's add a component. Let's write a new script, and this new script is going to be called spawn. That feels appropriate. The job of spawn is to have a slot for what it is you want to spawn in, which you can swap out if you want to. And also have it so it knows how long to wait between spawning, how much time has passed since the last one has spawned. You could keep a log on how many have spawned in and have a limit on that maybe. We could do all sorts of stuff, but let's play with randomness. First thing we need to do is set some variables up. So under line 6, I've just pressed enter to give some space down. We need a public float, which is going to be called something like first spawn time. I'm going to set that to maybe 2 seconds. And remember, if you do want decimal values, you need to put an F at the end in order to have it be decimal, because that is a whole number, I can get away with it. We also need a public float for wait between spawn, and maybe that's going to be 5 seconds. The idea here being it's going to be wait 2 seconds, spawn in the first one, then wait an additional 5 seconds, and then keep going. I think that is all I need to get this going. We don't need our start function, but what we do need underneath that my fault is a public game object, which we're going to call object to spawn. And that will be our prefab that will pop in place. Every frame, so on update, if no, I do need something else. I need to know the current time, which will also be a float, which starts life at 0. So if the current time is greater than the first spawn time, then we're going to instantiate something. Open and close sweetly brackets, and we instantiate, which is a lovely word to say. Practice it amongst yourself, guys, right now in lesson. Instantiate. It's a good word. Well done for speaking out loud in lesson. Appreciate it. We're going to instantiate the object to spawn, and then it needs to know where and at what rotation. So it needs two pieces of information here. So we are going to spawn it in at transform.position. Keep in mind the transform here is the spawn point position. Spawn in at the spawn point makes a load of sense. And transform dot rotation. The rotation of the spawn point, though, that doesn't really matter as much. Problem that we got, current time, which is 0, will never become greater than the first time to spawn because we're not increasing it. So every frame, the current time will increase by a number. So plus equals, and it's going to increase by time dot delta time. Notice the capital T because there is a time object, and delta time lowercase d uppercase t, semicolon to say that you're done. Notice there's no brackets after that. It's quite an unusual thing. So current time should be increasing. If the current time reaches the first spawn time, we spawn that thing in. What we also want to do is the first spawn time will also add something. So plus equals the wait between spawns. I could probably come up with better variable names for this, but these will do. So if the current time is greater than the first spawn time, spawn a thing in, and then the amount of time we need to wait before the next spawn is going to be added by the wait between spawns. So it should be 2 seconds, spawn a thing in, then wait 7 seconds, spawn a thing in, and then wait 5 seconds thereafter each time. Let's see if that works. So the spawn script is now expecting the slot for which object do we want to spawn. We can go into our prefabs and we can choose our cube, reselect the spawn point, drag it in, and remember those are our default settings that we've set in the script, but you can change it to your heart's content in the editor. With the game running, the current time should go up by 1 second per second, which is what we're seeing. Did it spawn in a cube? Yes, it did. That looks promising, and you can see that there's a bunch of cube clones being spawned in. However, they're all spawning on top of each other, so you can't see each one. I'm going to go to the prefab of the cube, and I'm going to make it a physics object, and this will force them to push away from each other as they spawn in. So I'm going to add a new component of type rigid body, which gives it physics. It will also apply gravity by default. You can change its mass, all sorts of settings as well. Because that's affected the prefab, it will affect every instance of them. So the first one should spawn in and it drops. The next one should spawn in and try and push away from the first one, which is the behaviour that we see. And if we leave it long enough, we'll just have so many cubes in our game that it will eventually crash. So let's have some fun and force this to happen. If I go to the spawn point and we see the wait time between spawn, let's just go over here and I really hope you won't break the recording. Wait time between spawn, let's change that to be 1 second. So now every second we should have them spawning in. And if you really want to break your game, set it to some decimal value like 0.001 and wait for the chaos to unfold. There we go. You could have your spawn point spawning coins. Ooh, that one's coming for us now. It will try and push you out of the environment as well. Have some fun with it. Have some fun with cubes. Oh dear. I'm boxed in, as it were. Great fun. So if you wanted to keep a log of how many were being spawned in, maybe your spawn point only creates 10 and then it will stop. So what we could do here is to keep a record of public integers, because it's going to be a whole number, num of spawn. Let's call it num spawn object. Starts life at 0. So currently we're saying if the current time is greater than the first spawn time, and I'm going to expand that if statement to have a second clause, a second part of it. So what I'm also going to say is if that is true, and, so that's 2 ampersands, which is shift and 7 on your keyboard. That's called an ampersand if you don't know. So we're also going to check if the number to spawn is less than something. I could hard code 10, or I could create a new variable that's called max spawn object. Set it to 10, and because it's public it will then be changeable in the inspector. So rather than coding it to 10, I'll set it to whatever the max spawn object value is. This now means no matter how ridiculous I am with my spawn points, it will never spawn more than 10. Hopefully. Just one more thing we need to change in the code, sorry, is because the number of spawn objects isn't currently increasing. So when we spawn something in, we now also need to say add 1 to the number of spawned objects. That's just in between those two brackets there inside of the if statement. So the maximum it should ever spawn is 10, no matter how ridiculous I am with my wait between spawns. Let's set it to something absolutely daft. So 2 seconds and then they all spawned in and I should have no more than 10. That's pretty cool. So if you wanted 10 enemies in your game and no more, you could control it that way if you wanted to. It's quite a niche example, but it's one worth delivering and explaining. So that's setting up spawn points. However, we want to use some randomness now. So maybe it's not a set pace. So let's use a little bit of randomness. The wait between spawn is what we're currently adding here. We're currently adding the wait between spawn, but I want to add some randomness to that value. So let's also add to the wait between spawn random with a capital R dot range. Notice how it's not random range, it gives us a note here to say that's depreciated. It will work, but it's not best form. It's random dot range is what you want. Random.range is a bit ridiculous. If you remember when we did the audio videos, we used random range to choose from a range of sound effects. If you haven't watched that one, go and rewatch that. I think we did it as a PowerPoint actually rather than as a recording session. But notice here that you've got the min inclusive and the max inclusive as well. There's some weirdness with the way ranges work. So I'm going to say add a random number between 0 and a number of your choice, and this will be a decimal value because notice how it says float there. So if I want to add in a decimal value, if I were to type in 2, notice how it now thinks, oh, it wants a whole number, right, so it's going to generate a number between 0, 1 or 2, wants a whole number, but we want a little bit more variety. I want a decimal number, so to force it to choose the decimal one, either put a decimal value in with an F to declare it as a float, or you could just put 2.0F and that will force it to be a float and give you the range of numbers between those two decimal values. You could of course create this as a variable up here and have it generate that random range each time, but now we will add a bit of variety to it. So let's add a random value of, I don't know, between 0 and 10 seconds. You can also add minus numbers if you wanted to. So you could have the minimum range be a minus number if you wanted to. Let's change that to again 1 second, but what you should see is it shouldn't be 1 second between each spawn now, it should be between 1 and 10. So I'm keeping an eye on the current time here. Should get a spawn in between there you go, between 2 and 12 seconds I expect it to spawn in, and now we're off to the races and it's anyone's guess. Probably before 20 seconds. There we go. And you can see that that's added a bit of randomness and variety to it. You can also use this technique if you had many spawn points to have a controlling script to say pick a spawn point in which you wanted something to spawn into randomly, rather than changing the time to be random. But that's more of an advanced concept, and we'll look at that at some point. If you want to know about that, give us a shout. So let's use timers. Currently we've got an element of UI, or we've got an element of information which is not currently being used or displayed to the player. Our player is keeping a record of their score, but that is not being displayed on the screen anywhere. And obviously when we create a build, that's not going to be very useful because I won't see it and neither will your player. But what we also need to do now is to create an element of a timer, and both of those need to be displayed on screen in some way. So we're going to start getting the UI for our queens to display. So we're going to go back to the queens script that we wrote previously. If you've not already got that open, double click on queens here where it's greyed out. We need to be using TextMesh Pro to change the text of something on screen. So in our queen script, we're going to also be using TM Pro. There we go. We're going to be using TM Pro with a capital TMP, TextMesh Pro. We're also going to create a public, so I'm just expanding the script here, public TextMesh Pro UGUI. Yeah, good luck guessing that one if you didn't know what it was. TextMesh Pro UGUI. GUI, if you don't know, GUI, Graphical User Interface. I have no idea what the U stands for in don't know what that U stands for, but GUI, Graphical User Interface, GUI. And we're going to make a reference to that, something like score text. So every time the score goes up, we're also now going to set the score text to equal, score text dot text, so the text of the score text. That's not a typo, but it does sound, you know when you hear a word too many times, yeah, score text dot text, you'll stop thinking text is a word. Score text dot text, I'm going to set it equal to something, and that something is just going to be the current score. Don't want that in double quotes, my fault. So I'm going to set it to the current score, but we have a problem. And it's actually telling us our problem here. Cannot implicitly convert from integer to string. Texts are string. So I could convert it to string by putting those double quotes back around it, but that won't display the score. That will just put the word score on screen, which is not useful. To convert something to a string, you type its name, dot, to string. Easy as that, as long as we use open and close brackets to finish it off. So in order to get that to work, we now need to put some text in our 3D environment. We haven't done this yet. We haven't put UI and 3D in the same scene, but let's do that now. It's easy. Game object, UI, text that uses TextMesh Pro, and notice you get a massive canvas. That's not where the canvas will physically be, it just needed somewhere to display it, and there we go. And if we go back to game mode and just make sure it's still set to full HD. This still represents your canvas. We can go into 2D mode while we're editing your canvas. You can put your text wherever you like, and remember this is the representation of where on screen you will see that UI. VR is different because VR is a physical object in the world, but for the purposes of making a 3D game that uses monitor space, what's called screen space, this will work fine. So again, I'm just going to increase the text, center align it, have its default just be equal to 0. The code will change that in a second, and choose our font that we set up in the previous one. Okay, and if we go back out of 2D mode and we go double click back on our player capsule, even though it looks like the text is up there, it won't be. It will just be displayed in the top right hand corner of your screen. Okay, you can see our disgusting looking 0, but as we collect things, we get our noise, but the score isn't increasing. The reason for that is the player capsule doesn't know what our score text is yet. Our score text is this piece of text over here under the canvas, so we can drag and drop that in, and it knows, Oh, you want me to change that bit of text, do you? Gotcha. So I can see my 0 up here. Perfect. Now that's all well and good, but it's not obvious to the player what that number represents. So what we're instead going to change is our text. Rather than just displaying a number 0, we're going to have it display the word score, colon, space. And we will need to change that in code again in a second. But what it will currently say is at the top right hand corner, score colon 0, and now it's going to 1, 2, 3. That's still not ideal. So in code, rather than displaying score.toString of this, we're going to display the text of score colon space, and then I want to do a plus symbol. Now that doesn't mean add, we're not trying to do mathematics here, we're not trying to add things together. What it means is also display. So I want you to display the letters SCORE colon space, then I also want you to display the score. Remember, space is as much a character as any letter or any number, so spaces matter if it's within double quotes. Let me just put that back on screen for a second because I know I did that very, very quickly. So score.text equals score, colon with a space, plus the score that we want. See what that does. And there you go, you can see that feels all right. So now we can tie in with timers. You saw how easy that was. We were using TextMesh Pro. We created a link to whatever we wanted to change, and then we changed it whenever we wanted to change it. Let's combine all of these skills together. I'm going to go back to the player capsule. We're going to create a new script. I could add it to the coin script, but it doesn't make sense that our coin script is monitoring our score. Each script should have its own distinct job. So we're going to create a new script here, and this is going to be called, we've done score, we're doing timer. Timer with a capital T. Notice you can't call it time. Time is a pre-created object. We used it earlier. We can't call something time, so we're calling this timer. I think it will be cool with being called timer, and we may have to change it in a second. Same deal as before. We are going to be using TM Pro. We need a reference to a public TextMesh Pro UGUI, which we're going to call timer text. We don't need the start function, but every update, sorry, we need a little bit more than that. We need a public float called the time. Notice I'm not calling it time because that's a key term, and the current time is 0, and we're going to every frame increase the time by time.delta time. Time.delta time, by the way, is the amount of time that passed between the last frame and the current frame. So that means that it's not increasing the number of frames, and it's not increasing at a set rate. It is dependent on your frame rate. So this means that the time will increase consistently. So every frame, the time increases by the time that has passed, and we're going to set the timer text dot text to equal the time. Remember, the time is a number we need to convert to a string. That's that done, basically. We're going to make it more complicated by recording it and passing that through other things. Same for this coin in a minute, but that's it done, basically. You can now see that has pulled through. We've got the timer, we're starting at 0, and the timer text. We now need to create a new piece of text for it. Back to our canvas, back to 2D mode, and I'm feeling particularly lazy. Control D to make a duplicate, move it down a little bit, maybe we want it there. So I've just put time as a 0. And if I go back to the player capsule, now it wants to know which timer text is. And notice I've got two things here called text mesh pro, and it's getting hard to work out which one's which. So naming things really helps. So I'm going to change the name of this to be something like score text. Doesn't have to match what we called it in code, just a way to find out what it is. And this is going to be called something like timer text. There we go. So with our player capsule selected, the timer text is going to be the timer text. That's way easier to find when you name things properly. That's why you should name your files in OneDrive correctly. Looking at you if you haven't done that in a while. So let's see what happens now. We've got score and we've got time, and that's not very useful, is it? Because what it is doing is showing the decimal value of the time that's incrementing, and you'll also see it bounce. Do you see how it's really twitchy? The reason why it's twitchy is we've center aligned that piece of text, so it's always trying to stay in the middle, but because it's such a varied word or varied length, it's not being very good and very consistent. And also we've got too many decimal places. Do we need all of those decimal places? So first fix. The timer text, I definitely want to align you left. Which probably means I want to align the score text left as well, because then we'll keep it nice and in line and it will look pretty. So firstly, does that solve our problem of it bouncing? It's not bouncing anymore, but it's still got far too many decimal places, and that's not useful information for us. So we need to do a little bit of maths jiggery pokery here. We need to cut it off at a certain amount, so we need to round to the nearest decimal place. So if you wanted to just have it display a whole number, this is really easy, because all you needed to do is to take the time.text, take the time. So before we converted that to a string, we would convert it into a bit of maths. Now I'm just going to work something out in my head. You don't need to copy this out. I'm just going to look at all the different things we could do to the time to make it help. So we can use our math functions, which is called mathf, math functions, by the way. It really bothers me that it's not maths. It's the Americans. They like their math. We like our maths. So we could round. We could round to the nearest whole number, round to int. As you guys will know, the way rounding works is it rounds up or down depending on where it is. So all I'm going to do here for testing is I'm going to put that in a variable, let's call it temp. Let it be a float and have it be equal to that number. So when I'm trying to debug something or come up with a conclusion, because basically what we're going to do is write it there. We're going to replace the time with this, but that will make the line look really, really big and difficult to read. So all I'm doing is writing a line, storing it in a temporary variable, which I'm literally calling temp. I'm just going to change to see does that look any better. It will store the whole number rather than the decimal number. Well, it will display it, I should say. Is that better or worse? 1, 2, 3. Maybe that's fine for your game. Maybe you like it being whole numbers. If you want a decimal number, let's see what we can do here to resolve that. It's surprisingly tricky to round to decimal places, if I recall. While we're here, round will round up or down. You guys will know the way rounding works. If it's below 0.5 it will round down. If it's 0.5 or above it will round up. However, sometimes you always want to round down, which is called floor, which rounds down. And if you want to go the opposite of the floor, well, what is that called? It's the ceiling. So you seal, which is the ceiling, which rounds up always. Sometimes that may be useful for you. But what we want to do is to round to a decimal point. I can't remember how to do that, truth be told. I can't remember off the top of my head. If you can find out, do share it in the comments. I don't even know if there are comments. negative infinity. What? Let's use that. No, can't think of how to do it off the top of my head. So we'll just round it for now. This is a solvable problem, but it's 10:30. So if you want to write that out for me, I'll just put a line of code in there. Float temp equals mathf.round of the time, and then we put it there. However, when we save it, we probably still want it to be the decimal value, which is what we're going to save to the player prefs, which I think we should probably do now. So we've set up and we've used timers. Kind of. We're going to have our failure state here as well. So what we're also going to do is, if it goes above the maximum time for our game, so let's create a public variable here, public max time equals, I don't know, if you're playing for more than 30 seconds, you're probably not doing a good job of this game, and it will be a floating point value. So every second, if the time is greater than the maximum amount of time permitted for this level, because you could apply this to each player in each level, you could have many different levels, we're going to go to a different scene. Notice the scene manager isn't there, and that's because we haven't yet imported it up here. So we need to be using the scene manager using Unity Engine .scene management. My fault, that's why I couldn't find it. So just under where we're using TextMesh Pro, but above the timer, we're using Unity Engine .scene management, which now means we can use the scene manager .load scene. And again, the name of the scene we want to go to, which we called lose. Now it's been an hour and a half since we wrote that thing, so it's I won't blame you for forgetting what that was called. So it's called load scene, and then with the scene was called lose. I've saved that. Let's play for 30 seconds. That's for testing. I'm just going to set it to 10. There's no point waiting 30 seconds. And you may find that's useful in your testing as well. Rather than having the full length of the game, especially for your VR project, no point waiting 10 minutes if you're going to set a timer to be 10 minutes. Set it to a reasonable test period, and you can have a degree of confidence that that will work. The player capsule, we've got our time which is increasing, 6, 7, 8. Okay, interesting thing, so notice how that has obviously gone past the 10 mark, and my script said 10, but because I saved it with Control S, it remembered the default. So whenever you set up your first default and you save it, that's what Unity will remember, and then you'll have to override it in the inspector. That's still 30, gets to 30, and we've gone to our lose screen. I can see that we're in our lose screen here, and we've got lose, and it's taking me here, but currently lose doesn't have anything in it. So far so good, so I'm prepared to say that that is done. Establishing win and lose conditions, well, we've set some lose conditions. Let's make a win condition. Should we do that first? Yeah, let's do this first. I'm going completely off the wall today. Why not? Let's have some fun with it. Recording the score in the player press to save between plays. This is really easy. So currently, if we reach the lose condition, we could keep a record of what our score was, or our time was at that point. What did I say here? We keep a record of the score. Record of score. Fair enough. Which is in coins. This does tie in with what I want to do. I don't think I'm going to change these scripts at the moment. What I'm going to instead do is to create another zone, a win condition, which I'm going to put here next to this pole that I think looks rather fetchingly like a flag pole. I'm going to make this flag, let's give it a flag pole, why not? What object is that? Is that primitives? Oh, your cylinder. Okay, fair enough. I'm just going to attach a plane to this. 3D object, plane. This may prove more trouble than it's worth. I just want this to look like a flag. Ugh. boom, looks like a flag. Seems like a reasonable goal to aim for. What we're going to do is we're going to tell that cylinder to have a zone around it. When the player enters that zone, it keeps a record of how many points you've got and stores that information when it takes you to the win screen or maybe back to the main menu. So let's go and do that. I'm going to create a child to the cylinder. So I've just right clicked on the cylinder, that will automatically create a child. 3D object, and I'm going to make a sphere. I don't like this. I'm going to undo that. Reason why I don't like it is because it was distorting the shape of the object in the same way you saw the plane had been distorted as well. So I'm just going to make a completely separate object. Game object, 3D object, sphere. I'm going to position that in the right place because it will have put it in the wrong place. I only care about the sphere's collider. I don't actually care about the fact it's a sphere. So I'm going to make that as big as I want the win zone to be. And I'm going to turn off the mesh renderer. I care about the collider, which we also need to make sure is a trigger, and I want that off. Now I could solve the next bit in two ways. I basically want to say when the player touches this zone, take me to the win screen. I could tell the player, if I touch this zone, go to the win screen, but I think it would be far more useful to have this sphere say, if something touches you, if that thing was the player, go to the win screen. So that's what we're going to do. Is that the best way of doing this? Yes, we can use some get components to pull some information. So that sphere is currently called sphere. I'm going to rename it to win zone. And I'm going to add a component which is going to be called win. Before I type win, notice that there are some pre-existing components called wind, W-I-N-D. So if I try and type win, it may try and add a wind zone, which is a force of physics. So just be careful when you're typing win that it doesn't try and add a wind zone to your script. So I'm going to create a new script called win. And the job of this script is quite simple. If something enters into the trigger zone, if that thing had the tag of player, then it's game won. Just to show you that the player capsule already has the tag of player, but maybe you will need to set that in your own games when you're making your own stuff. So the win script, I can get rid of all of this again. On trigger enter, if the other thing involved in the collision, if the other thing had the tag of player with a capital P. Let's change scenes. And if you remember, if we're using the scene manager, we need to be using the scene manager. Scene manager dot load scene, and we created a scene called win, if I remember, though it has been a while since we checked. Yes, and my scripts are getting really ugly now. I will move them into the scripts folder. So I've got my queens that can go in the scripts folder. I've got my Visual Studio may have a bit of a Barney as well because it's going. You're moving me scripts. Shouldn't break anything, but Visual Studio may just be a bit unhappy with you. So I'm just moving all of those things to keep it tidy. And it just has to do a quick rebuild because all the locations have changed. So let's test that. There's no reason why that shouldn't work. Let's collect a coin. We've only got 30 seconds to win this game. Pressure's on. Jump. There's our win zone. Jump. There we go. We've gone to our win screen, which with all its bland glory. Now what we're going to do is tell the win screen to display how long it took. So we're going to save that in the player pref. So we've got a win and lose condition. Boom, we've got a game. It's an awful game, like shockingly bad, but doable. Worth remembering as well, if you guys are wondering, would this pass the assignment? Would this get me through the VR project? Obviously it's not virtual reality, but would these levels of mechanics be appropriate? Well, I've taught you how to program this in 2 hours. You've got 16 weeks, and I expect you to use your 16 weeks to make 16 weeks worth of project. So it's up to you to answer that question. But if your game only has these kinds of features, probably needs more game in your game. So what we now need to do is to go to our scenes folder and go to our win screen and start populating it. 2D mode, game object, UI. I'm going to put my canvas in first, sorry, my panel in first, which will also create a canvas. And if I double click on canvas, there we go, that's better. Going to make the panel more visually interesting because this is our win screen. Let's still go with a fairly dark colour. High opace. You guys will quickly learn I have no sense of graphic design. This is Anastasia's forte. She's really good at this stuff. Me, less so. So I'm going to right click on the panel and create a new piece of UI. Text using TextMesh Pro. You are winner. That's suitably dreadful. Change the font to something appropriate. I can't have it misspelled that badly. There is a joke in there to anyone who gets the win joke, but there you go. So you are reasonable. You can make yours look as pretty or as interesting as you like, but there you go. I've got some text on the screen. But what we now want is some space for our score to go and our win screen. I know we put that on our main menu, if you remember. We've got our high score sitting there, but I'm also going to put it on the win screen. So I'm going to create in our canvas a new piece of text. And you can make this as pretty or as simple as you like. All I'm going to do now is just keep it really simple. Choose our text again, and that's just going to display the score. You could add a piece of text next to it that actually said your score is or whatever. But we can't do anything with this yet until we've set that code up. So back to Visual Studio. Going to my scripts because I've tidied everything up. We are caring about our coins because our coins are keeping our record of our score. And with my thinking cap on, I actually think it's the win screen we care about. So when we win, we need to find out from the player how many points they had and what their time was. Once we know that information, we can store it in a global variable which is called the player prefs. Player prefs is something the computer will memorize and keep a record of. It's not something the current version of Unity or your game will remember. It's not stored within the game, it's stored on the C drive of the computer that you did it on. So let's solve this. So if the other thing had the type of player, we also want to get the other.getComponent, and the other thing will have had a coins object on it. And coins knew some information which was score. Now if we've got any competent programmers in the room, people that have programmed before, what I'm doing here is an example of really bad coding practice, because what we've got here is score as a publicly accessible variable. I'm editing that directly through the win script, or the win script is getting it. And that's really bad practice because it introduces vulnerabilities. This is how code could be hacked. You could write a script that accesses another script which could cause conflicts and problems. What is better practice is to have a function, and that function's job is to return the score, because currently I could edit it through the onTrigger script, which probably doesn't make sense, whereas although what I want to do is to get it. But that's, when we get more time, we'll talk about better coding practice. So we need to get the score, and we need to store that within the player prefs. So let's put it here. to access the player prefs is really simple. Player prefs. So the player prefs is a global object, .set. And we can store a floating point value, an integer as a whole number, or a string. So you can't store whole scenes in here, you can't keep a record of what your scene was doing. It's really dumb. Straightforward, but really, really dumb. So I want to set a float, I want to keep a record of something, and it wants to know the name you want to keep a record of, and then the value. So the name, we're going to call it, in double quotes, is going to be score. Notice I'm using the word score in two different contexts here. The word score, I'm actually going to change this to high score. I think that's a little bit clearer what this is doing. We're keeping a record of the high score, and then the second thing, separated by a comma, we're getting the score that the player knows. End brackets, semicolon to say that we're done. So that will set the score, and then to display it, it's the same thing but in reverse. I'm going to copy that line of code. I'm going to check that it worked. So I'm going to go back to my playground scene, and I'm going to play the game. As long as it doesn't crash, that's a sign that that has worked. As long as we've got a score of 1 or above. With my mighty 1 score. Okay, I've got an error. No, that's just complaining about the input system. That is fine. So what we now need is a script that lives. Change scene coins. I'm going to put this in the score script. Does that make sense? I'm going to make a new script for this. Everything should have its own job. So let's create a new C# script. Let's call this display. Because we're going to display the score and the time potentially, let's call this display UI. So this is really simple. On start, we are going to get the player prefs. We are going to get a floating point value, and the name of the float we are getting, if you remember, is called high score. That's where we're storing it in the player prefs, and that gets it. Now we need to put it somewhere, so we need to have a record of the TextMesh Pro. We need to set using TextMesh Pro. We need a reference to the TextMesh Pro we want to set. TextMesh Pro UGUI, and we need this to be public, and we're going to call this score text. Going to call this score text win screen, just so it's slightly different in context. So when the game starts, the score text win screen dot text is equal to the player prefs, which will be a number which we need to convert to a string in order to work. So hopefully by now you're seeing that's a relatively long line of code, but each step is clear. Set the piece of text you want, change its text to equal whatever we're getting from the player prefs. And let's just talk through the logic here a second. You should never be able to get to the win screen without touching the point, which means that it will always have a score, so it will always display something. So that display UI, if we go back to our win screen, apologies for jumping between scenes all the time, but you will do this a lot as you're developing. I'm going to take that script, I'm going to take that script which we called something, display UI. Display UI I'm going to pop on the canvas, and then the canvas should now need to know, the display UI, what text is the score text on the win screen. Well, it's that piece of text there. If you're going to be really good, change that name to something like score text or something. And if you notice as well, it will just set it to whatever the score is. It won't display score is 1 or 2 or 3 or something. The reason why this is an imperfect solution right now, we're going to run this game 2 times. Didn't expect that. Oh well. No, I did. That made sense. It remembered from the last playthrough. So it remembered that we'd got 1 score from the previous playthrough. If we play this game and try and collect 2 or 3, there we go, we got a score of 3. If I do really badly and get no score whatsoever, I'm going to try and dodge the coins now. You'll see that we got a score of 0. So currently that's doing the job we wanted it to do, which is how much score did the player get in the previous game. But if instead you wanted it to be, does the current score beat their previous high score, that's quite simple. If you remember, we can get information or we can set information, player prefs dot get the float, get what's in the high score currently, and if that is greater than the current score, no, let me think the logic through here. If the current high score is less than our current score, then we update the score, otherwise we do nothing. That makes sense to me. Get the high score. If it is less than our current score, update it. That seems reasonable. So our current high score is 3. 1, 2. So it should remain at 3, 2. One more time. I'm not going to collect anything. Does it remain at 2, or have I forgotten how to code? It remained at 2. Okay, let's go get 3. Well, 5 will do. Score is 5. Good. I'm now going to collect no score. Does it remain at 5? Good, stayed at 5. Let me just double check my maths. If the current score is less than that, yes, I was just double checking whether I need a less than or equals to. That is correct. If the current high score is smaller than our score right now, replace it. That seems to work. Right, as an exercise for you guys, you can use the exact same kind of code to set up the score information on there as well. Sorry, the time information. It's exactly the same deal. So where are we right now? We've done that. And the last thing, which is the biggie. So tell your buddies, if they haven't got this point by the end of the week, give them a knock, because we need to learn how to create a build, because that's what you guys are going to submit to me over Teams, me or Anastasia, depending who your teacher is. To create a build of your project, you go to File and Build Settings. You can see the order of your build, making sure that your main menu loads first, otherwise that would be dim. You can see that we're going to build for Windows, Mac or Linux, which is the default platform. In my case, I've also got it set to build for Android, or it could build for Android, that's what I've got installed on here. But you can see you can build for PS5 and all sorts of stuff and all sorts of stuff, but we just care about Windows. If I click Build, it will say where do you want to make your build. What I would like you to do here is go into your Downloads folder, create a new folder. We created a complete game. and I want you to call it complete game dash your name. Select that folder. What that will then do is whir for a minute while it creates a build. This is a relatively short process. The CPU will spin up, so hopefully my voice won't go crazy while it's recording. Again, you can skip this bit if you're not interested in watching loading bars, move from left to right. If that is not your thing, you can skip to the appropriate bit where that completes. In this case, I reckon it'll take about 2 or 3 minutes, or less than. This will also resolve any lighting issues you have between scenes. A common problem students identify is when you're testing your game in the editor and you move between scenes, lighting can go very strange, it can go very dark. Creating a build fixes that issue as it rebakes your shaders, which is what you can see it's doing here. I said it would take about 2 minutes. Let's see how far off I was. For your own games, this process will probably take 10 minutes or more. There we go. What that will generate for you is a folder in your downloads, which is called complete game followed by your name. What you can see there is completegame.exe, and it will be very, very small. The actual exe itself is tiny because the data and all the other information includes it as well. When you submit this, it's either going to be on Teams as a chat to your teacher or going to be an assignment that will be launched. We have to use Teams because Moodle submission points I think are a bit too small for this. I will check how big this is, maybe we'll fit it on Moodle, but assume it's going to be on Teams, I'll let you know. Completegame.exe is what you'll double click on, and then the game should hopefully play. You get your nice UI element. There you go. We've got our main menu. Escape doesn't leave the game, by the way, because we didn't code that in. If you want escape to leave your game, you've got to put a bit of code in that says when I press the escape key, I think it's just application.quit. We've got our button which we can press, the game can start. We've got a score of 3. You've won the game with a score of 3. Notice how on this screen I can't leave. We didn't put a button in here to take us back to the game or to the main menu, so that's your job, is to now go and improve and fix that. If you are stuck, Alt F4 will get you out of the game as it currently stands. Remember, Alt F4 will close the currently open application. When you do come to submit this, you right click, you send that to a compressed zipped folder, and you submit the zip. How small is this entire game? 30 megs. Got the entire game under 30 megabytes. Maybe that will fit on Moodle. But that's what you submit, because you can't submit a folder directory either to Moodle or to Teams. You have to submit a zip, and that is what you'll submit on the day of the expo as well. Well, hopefully a couple of days before the expo. So, with that in mind, we've now created a successful build and built a complete experience in about 2 hours or so, 2.5 hours. Sizable video, this one. However, for bonus points, if you have got some spare time now in your week and you would like to add additional complications to this game, add an enemy that chases the player, make an enemy do damage when they're close enough based on what we've done before, make the enemy defeat the player when they defeat the player, go to the lose screen, animate the collectibles to bob up and down. I will add some more points to this as well, I think. I would like to reward people who add sound and music, really good UI, own custom sounds, custom visuals on their main menus, making better main menus than I've made because mine look truly shocking, but you can see the functionality is there. Hopefully that was useful for you, covered a huge amount of material. If you are sitting there right now and you're going, oh, I've done all of this, works, brilliant, I can now have a chat with me mate. If you've got any lesson time left of your week, you should be working on adding new features to your product. That's what you should be doing. Okay, thank you very much everybody, do take care.